I'm going to go on and use this exact equation we just used. X squared minus 6x plus 5. And I'm going to say equal y, to show you a couple of the next pieces of what a quadratic equation is. Do you remember we just factored this, right? X minus 5, x minus 1. Each of these is a form that has a specific name. The name of this form is standard form, just like we did with our linear equation. Do you remember that our linear equations, we had a standard form, we had a point slope form, we had a slope intercept form. Each of the quadratic equations also has different forms. The standard form here, when it's factored, I will call this on the side a factored form for your sake, but its actual name is the intercept form because it finds the x-intercepts. Why do I bother to tell you this? Well, basically because if you look at the extension after 10.2, this would be the easiest extra credit points on the entire planet if you do them. Essentially, all of that is the intercept form, and that's all they're introducing to you and how to play with that. So let's go back. What does the standard form look like for any quadratic equation? This is this specific one. It is ax squared plus bx plus c, which you've all been seeing, right? This is what I've been working with. And what does it look like here for the intercept form? A, because often before we got this, we factored something else. So they're calling that A. X minus, and instead of, because this could be any number, they're going to call this P just for the sake of having some variable. And again, this could be any number, and they're going to call that Q. Okay, and so that is the standard form and the intercept form. So that's the first thing I wanted to cover. You now have an easy way and a green light to do that extra credit extension, which just to give you the page, is on page, let's see, 641, 642. The second thing I'm going to show you to introduce is that when we graph quadratic equations, we have three options. So I'm going to draw three graphs. And this will go quickly. So first, we can have two solutions, right? Whether the parabola is face up or face down, you can have two solutions. Because these are the x-intercepts. So if it intersects the x-axis twice, right? These are solutions. So two solutions because two x-intercepts. Right? You can also have a situation where you have only one solution. And that is where it's intersecting the x-axis. Not actually even intersecting, it's the vertex is on the x-axis. So you've got so this is the x-intercept, but it's also equal to the vertex. They're both the same number. And in that situation, you have one solution. And the third option, I'm sure you've guessed, is when you've got a graph that's right all the way up here. Now it's intersecting the y-axis, but it's getting nowhere close to that x-axis. And so in this situation, you have no solution. there are going to be problems just going to ask you very simply, is this one solution, two solutions, no solution? What do these look like, right, in terms of your quadratic equation? Well, remember, for example, this is two solutions, right? You have an 5 and a 1. That gave you two solutions. Can you think of situations you would get only one solution? I'll give you a little hint. I'm actually going to write small so I don't mess you up too much with crowding this. I'm going to just give you this example as two solutions, x minus 5, x minus 1. What can you think of a one solution? Well, what about if you had x minus 2 squared, right? Which if you work out is x squared plus 4x plus 4, right? X minus 2 squared, well, both of these are going to be the same, x minus 2 times x minus 2. So the only solution is really 2, and that is what that's going to look like. And the no solution, goodness, I'm not going to give you, there are so many with no solutions. What that looks like is you try to factor for all you're worth, and you're going to use all the other methods I'm going to introduce you in this chapter, and no matter what you do, and you'll find out very clearly as we get to the quadratic formula how to determine that there's no solution. And you'll see what that looks like. Basically, it's going to be because you get a negative square root in the quadratic formula. So there's three possibilities. You've got two solutions, one solution, no solution. And I'm going to go on and give you three examples, and then we'll be good to go with homework.